Hi, welcome to the video where I compare the Lewis dot structure of covalent molecules to ionic compounds. And the reason why I'm going over this is because in both cases they're called Lewis dot structures, but they look very different and the process is very different. And that's because they're different types of substances. So let's recap what covalent molecules and ionic compounds are. Covalent molecules are molecules made up of all nonmetal atoms. So here we have an example. Nitrogen is a nonmetal and bromine is a nonmetal. They're made up of all nonmetal atoms, and the bonds are formed by the sharing of electrons. And you can see that when you look at their Lewis dot structure, the bonds are shown here that way. With ionics, on the other hand, ionic, when you see the word ionic, you see the word ion. Ion means something with a charge, okay? And ionic compounds are made up of ions, cations, positive charges, and anions, negative charges. And we know that, according to the law of electrostatics, things with opposite charges are attracted in the same way the north pole and the south pole of a magnet will be attracted to each other. There's an attractive force there. Now, ionic bonds are formed when the metal cation transfers electrons to the nonmetal anion, right? So, and that transfer process turns the metal into a cation since it lost electron, and the nonmetal to an anion since it gained electrons. And once they have that negative and positive charge, they'll be attracted to each other and kind of form a bond, like the north and south pole of a magnet. So because the types of bonds are different, the way that we draw the Lewis dot structures will be different. So let's take a look. We've already went over how do we do covalent, so you can look up this example here in the covalent Lewis dot structure video. But for ionics, our first step, instead of counting total valence electrons, we're going to focus on drawing the Lewis dot structure of each atom. And that allows us to figure out how many electrons the metal would lose and how many electrons the nonmetal will gain. Now, sodium is in group 1, so it has 1 valence electron. Bromine is in group 17, it has 7. I give each corner 1 and then I double up. Remember, it doesn't matter which direction you start off with. So, and you have to draw it for all the atoms. Here I just have 1 sodium and 1 bromine in the molecule. If this was, let's say, calcium bromide, and I had 1 calcium and 2 bromines, I would have to draw the Lewis dot structure for 2 bromines separately. Now I'm going to go ahead and transfer the electrons. I'm going to redraw it here quickly, just so we can sort of see the step-by-step process. So I'm transferring electrons from the metal. Oops, there should be a single dot here. Okay, from the metal to the nonmetal, and the reason why I do that, or why that's done, is when the metal, if you look at the metal, only has 1 valence electron. If that metal loses that valence electron, the next shell down will be a full shell, and that's what they're all aiming for. They're all aiming for a full shell. In covalent molecules, we call that an octet, and the same thing's happening here, where when the sodium loses that electron in the next shell over, it will be full. So it's easier for the metal to lose 1 than to have to gain 7 to get an octet. Whereas for the nonmetal, it has a lot of valence electrons. It only needs to gain like 1 or 2 or 3. In this case, with bromine, just needs to gain 1 to get an octet, and that's much easier than having to lose all 7 so that the next shell down would be full or satisfied. So the metal is going to go ahead and give its electron to bromine so it can have a satisfied valence shell, and the bromine is going to take that valence electron so it can have a satisfied valence shell. When it does that, the sodium becomes positively charged. And in this case, it's plus a positive 1 or plus charge because it lost 1 electron. The bromine, since it gained an electron, becomes negatively charged, and it'll be minus 1. And what we do to show that the negative charge and those electrons, you see how it gave it, bromine initially had 7, but it got 1 from the sodium, so it now has 8. I drew those 8 electrons around it, and I put it in brackets to show that these electrons belong to the bromine, and that negative 1 charge I put on the outside of the brackets. Again, that shows that it belongs to bromine. So this is the Lewis dot structure of sodium bromide. Now, if you were doing something a little bit more complicated, like aluminum bromide, all right, so that one has, so the formula for that is AlBr3. Again, you can follow these steps if you wanted to, draw the Lewis dot structure for all of the atoms, and then transfer the electrons from the metal to the non-metals, you could definitely do that. It is a lot more work, but it can be done. The easiest thing to do, instead of doing this, like drawing all the, just put this here, drawing all the Lewis dot structures, transferring it, what you can do as a shortcut for ionics is if you look on the periodic table and you focus, now what you're going to focus on, instead of focusing on valence electrons, you're going to focus on common charges. The metals will have a positive common charge, right? So aluminum, for example, is in group 13. The common charge or oxidation number for elements in group 13 is +3. Bromine is in group 17. The common charge for elements in group 17 is -1. So we know that the overall, so what we will do is we look at the formula and we'll draw aluminum with a 3+ charge. And since there are 3 bromines, we'll put a coefficient of 3 in front of the bromine, put the bromine in brackets, and the nonmetals always get an octet around them. So that's kind of the shortcut, and then of course don't forget whatever its common charge is. So that's a quick way. So now that we kind of reviewed how we draw ionics, let's just quickly compare the Lewis dot structures of ionics and covalent molecules. So they have very different processes. With covalent molecules, you want to focus on valence electrons, and when you draw the Lewis dot structures, the bonds are drawn as lines. For ionics, what you want to focus on are since you're transferring electrons and so you're forming ions, you want to focus on those common charges. So group 1 is +1, group 2 is +2, +3, blah, blah, blah. So you want to focus on that. The other thing is we draw the nonmetal with no dots around it because it lost the electrons in its former valence shell. And the metal, we always draw them with an octet of 8 around it, put them in brackets, and then a negative charge on the outside. You can put the metal in brackets too if you want to, but you have to put the nonmetal in brackets. All right. So whenever you're asked to draw a Lewis dot structure, before you tackle the problem, you want to check your formula to see whether or not you have a covalent molecule, all the atoms are nonmetals, or you have an ionic, you have metal and nonmetal. All right, and then you know which steps that you need to follow. I hope you found this video helpful. Have a quality day.